All right, I'm going to read this, and this comes from a standardized test. And I wanted to go to the bottom of the page and tell you about that. I know I've used quite a few of these problems, by the way. It's a sample question from an admission test. It's given, I believe, to high school students that are interested in a STEM career. And believe it or not, in this test, it also includes philosophy majors. And they're wishing to get entry into, I guess, probably the top school in the world, or at least one of them, Oxford University. All right. I mentioned over here that they use the term maths. We don't say that in the United States. We say mathematics. All right. Anyway, by some metrics, this is a tough school to get into. All right. It's probably the toughest school in the world to get into. I'm really not sure if that's true, by the way. You read some sites, they say this is the toughest one, that's the toughest one. But anyway, I believe they're good questions. I also believe that they're questions that, if you're given a lot of time, but students are not given a lot of time to do this exam, by the way. If you're given a lot of time, you'd probably get the question right. Now, if you're not given a lot of time, you're probably not going to get the question right because you're going to be puzzled by reading it. But let me read this over here. It says, a point A is on the parabola. They tell me that A is a positive number. So if I were to visualize this over here, I know the parabola, and it looks sort of like this over here. And I know there's a point in a parabola, and that point's going to be a comma a squared over 2. Pretty simple, by the way, all right? Then they said there's a line normal to the parabola. I want to point out a normal line is a line that's not tangent. It has at right angles, all right? It's at right angles to that. So I can figure that out. And then it says there's a distance AB, is a fixed positive number D. There's a distance now with B above and to the left of A. So I'm going to say B's over here somewhere, all right? And again, it's to the left and above it. This is the A, and that's the B. And when I say that's the x-coordinate of it, I'm sorry, that's B. So what I want to do is go to the questions. I kind of understand what they said, and there's a distance over here. I understood what they said, by the way. But now I got to answer their questions about it. And the first question is find the coordinates of B in terms of A and D. And we'll go to the whiteboard to do that. And again, I have the question in front of me. And it's like I'm not memorizing the question. So I'm going to write down what I've been given. I've been given a function, and that function is x squared over 2. I've been given a point on that function, and that point is a, comma, a squared over 2. I've also been told that a is greater than 0. The first thing I want to do is I want to get the normal line. All right, now to get the normal line, what I got to do is I got to take the derivative of f and get the slope of the tangent line. And I know that the slope of the tangent line is related to the normal line by being minus one over that value. So let's write this over here. It's going to be 2x over 2, which is just equal to x, by the way. So what's f prime of a? That's pretty simple. It's just a. So what's the slope of that normal line? I'll say the slope of the normal line. It's going to be minus 1 over a. All right? Question is, what do you do now? I'm going to write the equation down of the, I got a point, and I got a slope. And my favorite form of a line is this one over here, y minus y1 equals m x minus x1. So what I want to do is write that down. And what you're going to get? You can get y minus a squared over 2 equals, the m here is minus 1 over a, x minus, well, the x-coordinate is just a. Now, by the way, as far as I'm concerned, it's fine to write that way. There's nothing wrong with that. But I am going to simplify it a little bit because I think the other side looks pretty easy. It's minus 1 over a, x, and then you get, let's see, that's plus 1, isn't it, right? And then I'm going to write down y equals, that's going to be minus 1 over a times x plus 1 plus a squared over 2. All right? I'm going to continue to simplify because I like, y equals mx plus b2, by the way. This is the m, x, and the b, all right, plus this down, and one term, 2, and that's going to be 2 plus a squared. Okay? So this is the normal line. This is the equation of the normal line. At A. And that's the f of x, by the way. Now, I'm going to talk about the point B now, because if you go back to the question, it says find the coordinates of B in terms of A and D. And this looks like it might be tough to do, all right? So I'm going to say that there's a point B. So I wonder what the point B looks like. Well, if I said point A, and again, this was, we just did normal at point A, I'm going to say point B is B. All right? It's going to be B. But it's on the normal line. So what would that give me? All I got to do is plug it in. And what are you going to get? I'm plugging into the normal line. You're going to get minus B over A plus 2 plus A squared over 2. All right? Now, I do want to claim that I probably should pay some attention to what B is. And remember, A is here, B is over here. So A is greater than B. Now, that may not be important at this stage of the game, but I still want to make sure I have that, all right? Now, someone says, what are you going to do now? I got to do the distance formula, because they said something about D in the question. And so I'm going to write this over here. And what I'm going to write down is D squared, because I don't like to do the root. And what I'm going to do is there's 2 points I'm interested in, and the 2 points are going to be A and B. What was A going to be? A was A, and then it was A squared over 2. Now, what's D squared going to be? Well, let's take a look at it. I'm going to do, let's see, the change in the x, which is A minus B squared, plus the change in the y, which can be A squared over 2 minus B over A. That's plus B over A. And then minus 2 plus A squared over 2. And this looks really complicated. But let me keep working on it. I'm hoping that something nice can happen over here. I'm really not quite clear about that. But let's write this over. D squared equals A minus B squared. And I want to see if I can simplify what's inside here. And the first thing I notice is I got A squared minus A squared. And they're both over 2, so they disappear. So what am I left off with? B over A. And then what do I get? I get minus 2 over 2, which is just simply minus 1. That definitely got a little bit easier to look at. But I'm still looking at this thing. I'm wondering what to do now. So I get A minus B squared plus, I'm going to get one common denominator here, which would be A, and this would be B minus A. All right? Now, someone says, could you expand that? I could, but I'm starting to notice I got A minus B and B minus A. But before I proceed forward, I want to point out that B minus A, when squared, is the same thing as A minus B when squared. And that's easy to verify, by the way. So I'm going to rewrite this again. I'm going to write down A minus B squared plus, this is the same thing as A minus B over A squared. And then what I'm going to do is I'm going to multiply both sides by A squared. And what do you get? A squared, D squared equals A minus B squared times A squared plus A minus B squared. I multiply both sides by A squared. What I'm going to do now, I'm going to try to factor it. And I'm going to factor out A minus B squared. And then you could get A squared plus 1. All right? Now, someone says, do you remember what the question was? And I got to be honest with you, I don't. I'm going to go back and read it. All right? Go back and read the question. Find the coordinates of B in terms of A and D. So I have to solve this equation for B now. And the way I'm going to do that, I'm going to divide both sides by A squared plus 1. A squared plus 1. And I'm safe in doing that because I know A is greater than 0. They told me that. So what do you get? You get A squared, D squared over A squared plus 1 equals A minus B squared. Relatively simple, by the way. All right. What else do I know? Well, again, I know A is positive, and I got a distance over here. They tell me B was, to the left and above it. So The D's got to be positive too, by the way. All right? The other thing I know is I know that A minus B is a positive number. So I got some really nice roots here that I could take without worrying about plus or minus. So I'm going to say A over D is the same thing as A squared plus 1, the root of it. I'm taking the square root of both sides. A minus B. Can I solve for B? I can. And this is the finality of it. What's the B going to be equal to? Well, let's take a look at that. It's going to be A minus AD over the root of A squared plus 1. I'm going to put a box in this. Oh, maybe I shouldn't put a box. Read the question again. Find the coordinates of B. Well, you know what? I got to do that now. And the coordinates of B, right, in terms of A and AD, it's going to be B. And then someone says, I wonder what goes next. And I always say it's kind of peculiar, but I got to write this down. It's going to be that line, the normal line, evaluated at B, right? So let's go back to the normal line. And that was a long time ago, wasn't it? The equation along the line is this one over here. All right? Or this one over here. All I got to do is plug in B. That's all I got to do. All right? Let me write that down for you now. And I got to be careful about that. I think I already did that, actually. Maybe not. Let me write it down now. So what's it going to be? It's going to be minus B over A plus 2 plus A squared over 2. Again, what they want me to do is write the coordinate down in the form where I don't have a B in it. And this is what B is. So I think I can do that. And I'll write that down for you. It's going to be A minus AD over the root of A squared plus 1, comma. All right, here comes the tough part. I'm going to plug that in now. And I'm going to do that over here. So I'm looking at this here. I'm going to be plugging in this now. All right? And I notice if I do that, it really doesn't look that bad to do. Because what I have to do, I have to divide that thing by A and then add this onto it. And I think I can do that. And what are you going to get? Let me write that down for you. So I'm going to take the opposite of the B, which is A minus, you know what, I just have to make it a little bit neater than that. The opposite of the B I have to divide it by the A, and then I got to add 2 plus A squared over 2. Let's see what happens over there. What do you get? Well, I'm going to do this over here. You're going to get 1, and then you're going to get plus, I'm sorry, minus 1. Oh, no, I'm sorry. I didn't do that yet. So it's going to be what? I'm dividing by A. You're going to get D over the square root of A squared plus 1, and then plus 2 plus A squared over 2. Okay, what do you get there? You get minus 1 plus D, not plus, it's minus, right? You know, I'm making several mistakes here. I got to be careful. I always say I'm making mistakes, and I look at it and say, I see the mistake now. And let me write that down. I'm thinking forward, by the way, which is not good. So it's minus 1 plus D over the square root A squared plus 1 plus, I'm going to take this and split into two terms. It's going to be 1 plus A squared over 2. These things cancel off, and I get something pretty simple now. I get A squared over 2 plus D, and it's going to be the root A squared plus 1. And that was a lot of work, by the way. And I'm going to go back to the question and make sure I've answered their question, by the way. And I'll go back and read it to you. It was a long question, by the way. Find the coordinates of B in terms of A and D. I did. This is the coordinates of B in terms of A and D. And we are done. Thank you.